everyone, and welcome to the TDWI webinar program. I'm Andrew Miller, and I'll be your moderator. For today's program, we're going to talk about data quality modernization, evolving from rules to unsupervised monitoring. Our sponsors today are Databricks and Anomalo. And for our presentations today, we'll hear first from David Lotion with TDWI. And after David speaks, we'll have presentations from Dennis Dubow with Databricks and Zach Wright with Anomalo before moving into a panel discussion. Before I turn over the time to our speakers, please allow me to go over a few basics with everyone. Today's webinar will be about an hour long, and at the end of their presentations, our speakers will host a question and answer period. So if at any time during these presentations you'd like to submit a question, just use the Ask a Question area on your screen to type in your question. If you have any technical difficulties during the webinar, you can click on the Help area located below the slide window, and you'll receive technical assistance. If you'd like to discuss this webinar on Twitter with fellow attendees, just include the hashtag TDWI in your tweets. If you'd like a copy of today's presentation, please locate the resource window to download the PDF. And lastly, we are recording today's event, and we'll be emailing you a link to an archived version so you can view the presentation again later if you'd like. Again, today we're going to be discussing data quality modernization, and our first speaker is David Lotion. He's an affiliate analyst with TDWI and president of Knowledge Integrity, a consulting company focused on information management solutions for information quality, business intelligence, and metadata management. David is a recognized expert in information management and writes and speaks on the topic frequently, including at TDWI conferences and events. David is also a senior lecturer and the lead for external relations at the University of Maryland. With that, I'll welcome David, and I will hand it over to you now.
Thanks, Andrew, and thank you to our sponsors, Databricks and Anomalo, for giving me the opportunity to chat about this today and to have this panel. So what are we going to talk about today? Well, first we're going to set the stage. We're going to talk a little bit about embracing the cloud and modernization, and specifically modernization of a data environment. We'll touch upon historical approaches to data quality and focus on the need for sustainable and scalable mechanisms for data monitoring and observability, especially in ways that we can make use of emerging AI techniques that can augment automated anomaly detection and do so in a way that is simplified and low code or no code environment. So let's then we're going to go into our panel discussion. So let's dive right in. Cloud. The cloud environment fundamentally changes the way that organizations are looking at the way they make use of information, whether they're talking about their operational processes or more likely how they are combining information resources with the ability to better formulate reporting and analytics capabilities to address an expanding array of different types and classes of data consumers. There's a lot of benefits of migrating to the cloud. Cloud resources can be configured on demand. Cloud processing allows for a lot more flexibility, especially when you're looking at extensibility of different types of capabilities that are available through the cloud service providers or their value added companies that are developing tools that are targeted to be cloud native. Because there's such an array of cloud services that allows for more sophisticated experimentation of different ways that data can be used or combined or integrated or essentially exploited for a wide range of different business opportunities. Cloud computing is scalable. Cloud configurations allow you to bridge across a increasingly distributed landscape of data resources, whether you're talking about data that remained on premises or whether you've got data that's sitting in cloud object storage or cloud data warehouses or databases that were built for the cloud, or more likely, as is becoming apparent, data lakehouse architectures and data lakehouse configurations, which is a combination of different types of capabilities. And I'm sure we're going to hear a little bit more about that from our Databricks panelist. But one of the things that is becoming more apparent is that cloud workloads can make use of automation and can be configured to be drawing upon these different automation capabilities in a on-demand way, so it eliminates a large number of the need for an individual to be sitting with a finger on the pulse of a specific application to keep track of what's going on. So it really motivates adoption and use of automation across a long array of different types of data resources. Now, when we talk about that, of course, everything is in terms of data use is also dependent on data quality. And if we take a look at the conventional data life cycle or data analytics life cycle within the organizational structure from a logical perspective, we've got this kind of range of different stages: acquiring data, which is either creating data or purchasing data or collecting data or extracting data from other sources or bridging through APIs to other resources as well, and then ingesting that data. So we're at number 2, modeling, integrating, and organizing data, preparing that data for use through standardization, validation, engineering, using the data in either modeling or using different types of analytical techniques, visualization, etc., followed by presenting what results we have. So presentations, sharing information. I'll put the word storytelling in quotes there, and then finally the underlying need for management. So storing data, structuring data, accessing data, data fabric, preservation of data, archiving it, and ultimately destroying data. Now, if you look at kind of like between stages 3 and 4, that's where data quality is often being introduced in the traditional way, either in the standardization validation component or prior to its use, before it is being subjected to the type of reporting or analyses or modeling that is becoming pretty standard in most organizations. But what we're finding is that data quality actually is inherently necessary across all phases of this data analytics lifecycle. So data quality should be monitored, observed, reported on, and essentially addressed across the entire analytics lifecycle, whether you're talking about at the acquisition point of the data or at any of the subsequent stages prior to the point where you get to the management and archiving or destruction or moving data, et cetera. So data quality, the traditional approach to data quality, which focused solely on cleansing data at one particular point, is insufficient to meet the needs of an expanding multi-cloud hybrid environment. So if we look at our data lakehouse, we've got all of our different sources of data that are essentially, again, moving data into kind of cloud object storage or really maintaining data within its own operational or administrative domain, and have a lakehouse configuration allowing for data platform services that gives some kind of data literacy or data awareness to the data consumers through a data catalog and accessibility to these different data resources at a logical level as conceptual objects through data access services or a query engine which embeds or integrates the ability to take a query or a request for data and translate that and boil it down into its component pieces, pull the data and be able to reconfigure or reattach all the result sets into a logically representative output or result set that can be presented to the data consumer in a way that essentially hides the complexity of the different architectures to the data consumers, but also provides a streamlined mechanism for allowing the sources to not have to commit to somebody else's idea of a data model in a structured data warehouse the way that we've been doing it for the last 3 decades. But there are some challenges associated with managing data quality in this environment, aside from the necessity of enforcing data requirement compliance when you've got this data distribution architecture. So this distribution of data becomes a point of complexity because you want to be able to ensure that any data consumer knows what it is that they're looking at and is able to trust the result sets that come through based on what their needs are, what their expectations are, what in addition what their access privileges are as well. But we also have the typical issues that we need in terms of any kind of computing, which is scalability of the data quality and data observability, sustainability, especially as you get a growing array of data consumers, explainability, so that you've got some mechanism for explaining how the data that is being presented to the data consumers were configured, and what types of rules or what types of validations were applied along the way, anomaly detection and identification, and then continuous monitoring to make sure that the level of quality remains at a predictable level for all data consumers across all different aspects of this data analytics lifecycle. So there are some emerging opportunities in terms of data quality, especially in a cloud or a multi-cloud environment. The application of artificial intelligence and machine learning techniques to augment the traditional approaches, and this includes things like pattern recognition, pattern analysis, inferencing, regression, and then the ability to introduce unsupervised monitoring, which takes away the burden of trying to figure out or anticipate what the type of problems that might be, because you've got the ability to do discovery of emergent anomalies and be able to review that with the data quality analysts and the data quality specialists that then allow you to do automated detection and notification, and in fact, even data correction. So some of the key discussion points that we're going to talk about are in terms of data quality modernization. We've got two facets of this. One is the core issues that have to do with any environment where we've got increasing volumes and increasing distribution, which are scalability and performance. And then we've got the second array of topics which have to do with modernization of your data quality strategies, including automated validation, automated anomaly detection, ongoing continuous monitoring that is aligned with that anomaly detection, then unsupervised techniques for discovery and monitoring and correction. So that being said, I think I'm going to hand it back to Andrew, who's going to introduce some of our panelists.
Thank you very much, David. That was a great presentation. It is now time for us to introduce our next speaker, who is Dennis Dubow with Databricks. Dennis is a partner solution architect providing guidance and enablement on modernizing data lake strategies using Databricks with partners. Dennis is a seasoned professional with significant industry experience in data engineering and data warehousing, with previous stops at Greenplum, Hortonworks, IBM, and AtScale. Welcome, Dennis, and with that, I will pass it over to you now.
Thank you, Andrew, and thanks, David, for setting the stage and touching on the data lakehouse. And Databricks first introduced the data lakehouse concept in January of 2020. This was the new architectural paradigm shift that we saw in the industry. We touched a little bit on data lakes and warehousing and a combination of those two technologies, producing a data lakehouse strategy. So in the next few minutes here, I'll basically introduce you to the data lakehouse concept and how Databricks has basically evolved into this. Now, just a little bit about Databricks. We're the inventor and pioneers of a few open source projects. I mean, Delta Lake is one that's now part of the Linux Foundation, as well as MLflow and our newly Delta sharing project as well. You probably know Databricks about more around the Apache Spark, which is part of the Apache Foundation. But we are the inventor and the pioneer of the data lakehouse. We're now over 5,000+ employees globally around the world. We've exceeded $1 billion in revenue, starting from Fortune 500s to unicorn companies. So we have very small commercial customers using our Databricks solution, as well as extremely large and global and strategic customers out in the industry. we're recognized by Gartner in the top quadrant in database management system and data science and machine learning platform. So those are pretty difficult quadrants to reach, both of them at the top of the the echelon. So, all right. So, I mean, this is just a really a glance at the different industries that we, and some of the customers, obviously. So the thing to remember here is, again, most Fortune 500 companies, at least more than 50% of the 500 companies are using Databricks today. And these are some of just a snippet of some of the logos, the different verticals in which we have a representation and the customer that we're working with. A few statistics here as your eyes are going through the different logos. Obviously Databricks has many different customers in financial services industry, across banking industry, insurance, capital markets, and fintech. We have a really good representation in media and entertainment. We actually have 9 out of 10 of the largest pharmaceutical companies in the world, as well as 8 of the 10 largest healthcare companies that are actually using Databricks. And the one thing to remember here is, if you see a competitor on the slide, is that customer is actually right now democratizing data analytics and AI, and it's all done using the Lakehouse. Now, companies have been, really focused on data. This is not a new topic. I mean, every company is working to be more focused. They're in the pursuit of going as, and remember that they want to be data driven. The journey is very difficult, and we know that our mission is really to help these companies democratizing data and analytics. Now, we know that this is not simple, and whether you're looking at the different capabilities of your industry, whether you're attempting to facilitating and bring relevance and hyper personalization to your touch points from a customer lifecycle perspective, or applying predictability and precision to drive performance with your products, you'll probably try to unlocking productivity through automation and self-service and self-insights for your workforce, and optimizing both internally and across your partner ecosystem for supply chains and all your business, and maximizing profitability with your business operations. But we know that this is very difficult, and most organizations are still struggling with this. And it's an endeavor that most organizations are in today. So today you can probably have, if you're a large enterprise or even a small enterprise, you probably have a different components that you're using to deliver insights to your business. But think of it from a platform perspective, and then we'll just look at the cloud, whether you're on AWS, Azure, or Google Cloud. You probably have one of these components, and you have to probably stitch them together and having different DevOps team to manage all of these different components. You most likely have a data lake, and then we'll just speak on AWS today, but you probably have an EMR for big data stack using your data lake and S3. You probably have a Redshift and a warehouse, and you have orchestration. You're using probably step function to organize the your big data stack, and you might have a managed airflow. You have a business intelligence component. You have a SageMaker for your data and science, and you have a streaming component with Kinesis. And then you get into governance with either you have a catalog, you might have a lake formation component, or even the new announced data zone. So there's a numbers of different components here, and this is really hard. It's hard, and it creates silos across these different components. It's very difficult to assess and provide consistent policies. And you have disparate tools and different systems together, and it's super complex, and it's very expensive to manage. So the data lakehouse has a different approach. It starts with your cloud data lake. You have one platform to manage all your types of data. You have one security model, one governance capability, and you also address all the different personas of your enterprise, from your data warehousing and BI to your data engineering and DevOps to your data streaming and data science. And how do we do this? Well, with Databricks, you start again with that raw data, which is stored either on your S3 ADLS or GCS cloud storage. Delta Lake is the file format that unifies data lakehouses and data warehouses. Unity Catalog is the catalog that governs all these data assets together, as well as all the other components that you have, not only just data, but down to notebooks and models and feature stores and all the different components that you need in your life cycle that addresses all your personas via a single pane of glass, providing we have the different functionality like our Databricks SQL or Databricks workflows, Delta Lake table for streaming, and obviously our ML, including ML flow. Now, most of you have something like this in your enterprise, which is very complex, and I'm not expecting you to read all this. And in all disclosure, A16Z produced this diagram. A16Z is one of the early investors in Databricks, but they also have a rich palette of investment now in the modern data stack, partners in this ecosystem. But the key here to remember is that it's very, very difficult to do all this in one platform. And we understand that customers have made investments, and Databricks has invested significantly in a very rich and strong ecosystem. Now, Databricks has a numbers of different partners. This is, again, just a snippet of some of the partners that we have. We also have what we call a Databricks Partner Connect platform that's fully integrated in the Lakehouse. And Anomalo is one of our partners in Partner Connect. So you're using Databricks as a single Lakehouse, single pane of glass. You can address all your personas and all your capabilities of the enterprise as needed, while as well launching a customer experience where you can actually initiate and use some of our partner solution to complement and then making sure you generate business insights as rapidly and as efficiently as possible for your stakeholders. So on that's the end of my presentation today. So back to you, Andrew, and thank you for your attention.
Thanks very much, Dennis. Really appreciate that. That was a great presentation. Now it's time for me to introduce our next speaker, who's Zach Wright with Anomalo. Zach is a data analyst and data engineer with a strong background in analytics, data prep, and data quality. While managing analytics teams and building custom enterprise data products for Fortune 50 companies, he saw the dire need for a scalable data quality strategy. He has since become a strong advocate for empowering businesses to leverage machine learning to automatically detect data issues and understand the root causes, ultimately enabling them to make more informed decisions based on trustworthy data. Zach's previous roles at Tableau, Capital One, and Comscore, coupled with his academic background as an engineer at Cornell University, have driven his enthusiasm for intelligent, automated, and self-serviceable data quality. Welcome to Zach, and I will pass it over to you now.
Thank you, Andrew. All right, so we could get started. Again, my name's Zach. I used to be a data engineer, QA analyst, BI in finance and at Tableau. So data quality is something that's really near and dear to me. My entire career has been completely plagued by data quality issues, and that's why I ended up joining Anomalo. So what is Anomalo? Well, it's the automated data quality platform that can automatically detect anomalies in your data and find the root cause. And it resonates with me a lot because this is something I could have used throughout my entire career. It would have saved me a lot of time and would have saved me from the embarrassment of propagating issues downstream for analysts to output the wrong results. So let's set a backdrop for the modern data stack. In the modern data stack, of course, we have a lot of different pieces. At any one of those parts of the modern data stack, data quality issues can arise. So first, at ingest, data quality issues can occur, such as I might not even get my data, or the data might not be complete, I might have missing values. And then once they go into the enterprise warehouse, those issues can propagate downstream. But not only that, new data quality issues can be generated through the ETL process or through orchestration tools like Airflow. And this is a big problem because lakehouses and warehouses, specifically like Databricks, are my source of truth for my analysts who ultimately make decisions for the business. And the only thing worse than making decisions on no data would be making decisions on bad or wrong data. So data could be delayed. There could be anomalies in the values, things like distribution shifts, and this can really affect the business. So also downstream, more data quality issues can occur, such as if I were to create a dashboard and I miscalculate a metric, that could be bad data, as well as if I'm a data scientist and I am training my models on the wrong data set or a wrong part of the data set, then that could also introduce anomalies. So how do I monitor the data in a scalable way? Well, there are going to be 3 different categories of checks overall that I'd want to implement to have a complete data quality monitoring solution. As a data leader, I need to have a complete holistic coverage. So the 3 categories: first, validation rules. And these are going to be rules that a lot of data engineers know and love, familiar with today. And these are things that I'd want to check at a record level. I care about every single value in a column, for example. None of them should ever be null, or they should follow a regex expression, for example. And these are great because they get really granular. I'm getting really down to the record level. But where they might come short is in scalability. If I have a lakehouse of 20,000 tables and I have 100 different validation rules on each one of those, that could be really difficult to maintain, especially over time. So has its benefits, but it is limited in scalability. The second category would be metric anomalies. And these, instead of looking at a granular level, are instead looking at a very high aggregate level. And usually business users might care about these. So there might be business metrics like KPIs, such as the average sales on a monthly or daily basis that my business is making. And because it's at a high level, I can get a holistic overview of the things that are really important to my business and make sure they are never deviating. But at the same time, in a very large lakehouse environment, the more metrics that I add to check and monitor, the higher a risk I put myself at to receive false positive alerts. So even though these metric anomalies are going to be using time series models, which will move with the data, it'll come down to statistics at the end of the day, and I could be receiving false positive alerts with a lot of them. So finally, there's unsupervised data modeling. And this is a very, very new way of monitoring the data quality in my lakehouse. So what this is going to be doing is casting a wide net across my entire table by taking just a sample and determining if the data from yesterday's data has shifted or drifted in any significant way compared to historical data. And it does this in a completely automatic way. So I don't have to configure specific things to look at because it's unsupervised. It's going to look for any type of drift. And this is going to be really scalable for me in that it's going to be automatic across all tables. Now, where it might fall short is it's not going to look at a very granular level, and it's not going to be targeted. It's only looking for significant shifts. If it were to look at very targeted parts of the data, then it could send too many alerts. Now, as a data leader, I might be tempted to say, okay, let's keep doing all our validation rules, all our key metrics as we've done in our legacy system, and maybe we'll even add more. And then the unsupervised data modeling is just a bonus on top of that. But I could operate under a different paradigm where instead I'm starting with a foundation of unsupervised data monitoring in which that can detect significant shifts in the data. And it could even find the unknown issues. But for the things that are really important, I would add the validation rules and metric anomalies. So this is going to be more scalable for me. Now, detecting anomalies is a very important part of data quality monitoring. When I used to be a data engineer, I wanted to spend a lot of my time creating data products, but I often found instead 50% of my time was trying to figure out why data quality issues were occurring, and specifically where in the data they were happening. So Anomalo automatically generates a root cause analysis. As soon as it detects an anomaly, it will run through the root cause analysis, and this will help speed up the time to resolution for me. I'll get direct insight into where on the data an issue is occurring. On this specific slide in this visualization, there's significant evidence that my data issue is arriving from the point of sale that is located in New York. So I know to address it here. So for a modern data quality solution, I want it to be very intelligent and the one that detects issues and finds the root cause, but I also want to make sure that user engagement remains high. And if I receive too many false positive alerts or too many notifications that I don't care about as a user, that aren't important to me, then I'll begin to check out of monitoring the data. I just don't want to look at the notifications at all. And for a data leader, if I have a data team that isn't using the data quality tool, it's like I'm all the way back to square one and I don't really have data quality monitoring at all. And no one's really looking at that data quality. So this would be a really big issue. Now, Anomalo has a lot of different false positive suppression techniques. It's going through a lot of models that will make sure it's only alerting on the very significant issues. And beyond that, going back to the unsupervised model, this is a way for me to reduce the number of redundant checks by automatically looking for significant shifts. And so with fewer checks, only the ones that are really important, I'll be receiving fewer false positive alerts. Now, not only do I want to prevent users from checking out of monitoring data quality, but I also want to proactively engage users into monitoring data quality. Now, we've seen in the modern data stack over the past few years, this incredible democratization and self-serviceability across lots of different tools. So, for example, in Databricks, it makes it really easy to access these large data sets across a warehouse, really easy to apply data science models. More users can interact in that way. And on the other side, maybe in the world of BI, we've seen a huge shift from legacy IT tools or IT dashboards over to self-service visualization tools, such as Tableau and Power BI, where someone could go in, ask a question on their data, and then immediately make a change and get an answer. So why wouldn't that be the case in data quality monitoring as well? So this would absolutely be done in a governed way with proper permissioning, but an interface that is really simple to use would empower all types of data users to contribute to data quality monitoring. As an end user, maybe I'm a BI analyst, there are certain metrics that are really important to me. And I just want to make sure that those metrics are always okay and get alerted if they're not. So I would be able to go into Anomalo, and there's going to be over 100 out of the box, no code or low code checks. And from here, I could just click a few times and I would automatically be monitoring that metric. So if anything I've been talking about has resonated, if there are certain data quality pain points, such as being able to scale or finding that anomalies are slipping through the cracks and the time to discover them is too long, then you could head right into Databricks, go down to Partner Connect, and from there you could just have a free trial of Anomalo, or feel free to reach out to me. I'm happy to answer any questions, set up a call, go through a demo. But yeah, hopefully this was helpful. So I'm going to pass it back to Andrew. Thanks for the time.
Fantastic. Thank you very much, Zach. Really appreciate it. Now it's time for us to transition into our panel discussion. So I'll ask that both David and Dennis rejoin us, and Zach, you'll be there as well. Before I pass it back to David, just a quick reminder to the audience that you can ask a question here at any point in time if you'd like to. Just use the Ask a Question window to type in your question. We will be answering audience questions in the final portion of our program. So with that, David, I'll pass it over to you for the panel discussion.
Thanks, and Dennis and Zach, those were both really good introductions to the foundation of what we will be chatting about. And before I even dive into some of those, though, I think that we have to start out with what seems to be on everybody's lips these days, which is ChatGPT and large language models. I tinkered with ChatGPT. I was impressed by the capabilities. that it could provide, but I was extremely disappointed by the quality of the results. So, Dennis, let's start with you. What do you have to say about LLMs and the expansion to cloud environments and widespread data distribution, and then in addition the questions about data quality?
All right, so let me unpeel because I think there's 4 topics in here, right? So LLMs, I mean, you've probably seen in our response to ChatGPT, Databricks demonstrated that our platform is capable and able to build LLMs really rapidly at a very low cost. So Dolly was an experience that basically in response to ChatGPT to demonstrate to the industry that you could do this today with the capability of the lakehouse. Now, having said that, to your point, ChatGPT and GPT-3 or GPT-4, I mean, these are really large language models. And I mean, it's a combination of actually of a series of smaller models, right? And I think the industry is going to probably most likely gravitate towards numbers of small and more specialized models as we move forward. So maybe the large is going to kind of just go to the medium-sized language models, possibly with very more specific. At least we're seeing this ourselves today. Numbers of our partners and customers have actually embarked on that journey. We are actually introducing LLM models in our platform. We're building assistants. There are some very core competencies for this, specifically around documentation. So we're feeding our entire documentation system into these large language models so that we can have a better, answer and quicker answers for our customers. So there's applicability for this. I'm not saying that LLMs are goods for everything, as you pointed out. They're very generalized right now. So LLMs. I think it's just a moving forward, and I would encourage everybody who's listening today, if you haven't done that, I mean, just get acquainted with that. I mean, it's here to stay. I mean, it's just going to evolve, I think, more and then fairly rapidly as well. And then we see that a lot of our partners in our ecosystems are actually adopting LLMs in some shape, way, or forms as part of their products.
Thanks. Zach, how about some perspectives on the whole data quality angle?
Yeah, sure. I would say from a data quality perspective, large language models are just taking what it's seen based on how it's been trained. And when I ask it a question, it's going to return what it sees as the best answer based on the data it already has. So for an example, if I were to go to a much smaller language model, when I worked at Tableau, they have a feature called Ask Data. And what I could do as a user is just type in a question for any given data set. And Tableau would interpret it and return a chart of what it thinks I'm looking for. Now, its interpretation would more often than not be correct, and I would get the chart that I was asking for, but the data underlying that chart still might not be right. And what I'm seeing, the insights I'm getting, are not what I should be taking as fact. So what I have tried doing recently with LLM models is, instead of interpreting what they're returning as here's what you should do, it's more here's what I found. And it's going to come down to the data that's actually input into it. So if it doesn't have the right data to train on, it won't be providing the right answers.
Right, well, that's great. Now that we've kind of gotten that topic out of the way, one of the bullet items that we talked about in the abstract has to do with data governance, data quality. As organizations are migrating or moving or even going cloud native, from cloud for birth, what are some data quality and subsequently some data governance issues that have become more acute when you look at a hybrid multi-cloud landscape as opposed to either just on-prem or a replication of an on-prem footprint in a particular single cloud implementation. And Zach, I'm gonna toss this to you first.
Yeah, sure. So I think first and foremost, what's going to be really important is the data quality issues that could arise during the migration process. If I am going from a legacy data warehouse such as Teradata or Oracle onto Databricks, every single table or source of the data that I move over to Databricks could be at risk for introducing data quality issues. So I need some way to both monitor the data that arrives in Databricks and also a way to compare the data to what's in the source. And a way I could compare it is by grabbing aggregates of metrics, such as the sum of a metric or the average price of a product I sell, and being able to compare it from Databricks over to the original source. But I would also want to do that across lots of segments. So maybe at a high level, it could be the same, but there could have been shifts within the data. Maybe the average price per sale is different for the West Coast or for the East Coast, even though the total average price is the same. So I need a way to do that. The second thing is just monitoring the data that is coming in. Is it fresh? Is it coming in on time? Is it complete? Are there missing values? Is there any significant drift that I wouldn't expect so that I could look back at the source table? So that would be a high level overview of the actual migration. But beyond that, as companies and users are going on to these cloud lakehouses like Databricks, they're just finding that the performance is a lot better and more can be queried. And so more questions can be asked, or the questions that were asked before that they just didn't have the database resources to answer, they now do. And so more tables and more data sets are becoming relevant. And so they need the data quality checks as well.
So I'm gonna modulate the question a little bit for Dennis. I think I want to kind of focus on the architectural paradigm of the lake house, and kind of the under the hood components of that, which is essentially being able to have a greater flexibility with respect to distribution of data across different types of underlying architectural platforms, but still wanting to be able to provide kind of a unified perspective or accessibility to the data consumer. So with that in mind, what are some of the, now I'll kind of focus on the governance aspects. What are some data quality and, more importantly, data governance issues that become more acute in that lakehouse environment?
That's a great question. And obviously, as you move your data to the cloud, in the lakehouse, providing the ability of a data lake as well as a warehouse, and unifying those two general systems under the hood of a lakehouse. Databricks saw that evolving over the different clouds. I mean, the Databricks is supported on all three major hyperclouds, and each of those clouds have a catalog strategy, and let alone the third-party catalogs that you see in the industry. And then how do you consolidate governance and data accessibility, as well as data quality as you ingest that data into these different clouds? Not to say as well that most large enterprises are multi-cloud today, and hence the birth of the Unity catalog. So with a single catalog capability on the lakehouse, you can govern assets across multi-clouds. You can also do data discovery. You can also manage all your governance and your assets. So I touched a little bit on that on the presentation rapidly, given the time that we had. But in that centralized capability, centralized catalog, having the ability to search for your assets, having to understand the policies and the governance that are given at the data attribute level, and not only on the data itself, but on all the other componentry that you have as part of your lakehouse, whether it's a model, whether it's a feature store, whether it's a dashboard that you're producing and sharing with with an audience. So through that single pane of glass, that single Unity catalog, you have that ability without having to all these disparate tools. And I made a comment about AWS today. They have about 3 different solutions, let alone adding the third-party solution that's available. We are very picky in terms of how we build our partner ecosystem, and Anomalo is one of those solutions that we've decided to basically work with. And we're really grateful that Anomalo is one of our partners. But we're really picky on how we complement that solution, and providing that additional governance capability. We understand customers have options, and we want to also make sure that part of the modern data stack that we provide our customers the best integration possible. All of these partner integration, including Anomalo, is integrated with the Unity catalog. So that's the foundational piece for for the governance.
So let me kind of drill down on that. You talk about partners and Unity catalog, which is clearly is a critical component in any kind of perspective on an enterprise data landscape. Zach, can you talk a little bit about how Anomalo is aligned with the componentry and the capabilities in the stack that Databricks provides?
Yeah. So Anomalo wants to be flexible. What Anomalo wants to do is be able to connect to the actual data so it can monitor it, make sure the quality is good. So it's just going to be a matter of coming down to connections. So through Unity catalog, for example, or the Hive Metastore, it wants to be agnostic to that. And beyond that, be able to surface those data quality issues wherever it's needed. So there's a REST API, for example, in Anomalo. And if I want to take results of checks, for example, if there is a deprecation in the table, if there's an issue that Anomalo found, that I could grab that and put it into the catalog. So any users that are looking there would see that in like a description there. So if they're navigating through, they would be able to know, hey, before I query this table, I should just be aware of this data quality issue. Is this going to impact my analysis?
So Zach, I'm going to go to you on this next question, which actually I'm kind of curious. You work with other companies, you work with your customers. You've looked at the data yourself. Can you share an experience where the capabilities that you described, the unsupervised monitoring, has surfaced issues that were completely surprising?
Yeah. I can think of a very poignant example. So we work with a very large credit card company in the United States that takes data feeds from multiple credit agencies, such as Experian. And it uses all of those credit scores that the credit agencies sends them to determine what credit limit they should be giving their customers. And that credit limit is really important to set at the right amount, because if it's too large, then the customers that they have could be more likely to default on their credit card. And a lot of money can be lost there. So earlier in 2022, Experian actually had a severe data quality issue where they unknowingly sent false credit cards, false FICO scores to credit card companies, such as one of our clients. And this, if it weren't caught, would have created a model in which this company would give credit card limits that are way higher than they should be, specifically like $1,000 to $2,000 higher, and a lot could have been lost there. Now, because it was detected very early, action was able to be taken in which hardly anything was lost there. And not only that, because the unsupervised model detected it, it was like an unknown issue. No one thought to look for significant shifts in the distribution. So even if I do have a scalable way of creating a lot of validation rules and key metrics, there's still always going to be some anomalies that would slip through because I don't know to look for everything. And after it was detected, Anomalo generated an automatic root cause analysis, and immediately it was seen that, all of these issues are coming from the data feed we're getting from Experian. And so the speed to resolution is a matter of a couple days rather than over a month.
That's an interesting case there, and certainly it's interesting because I've seen similar scenarios where those unknown unknowns can be quite shocking when you actually find them. So I'm going to ask one question to Dennis. Sounds like when you're starting to do integrated observability, monitoring, unsupervised monitoring, et cetera, those types of things that partner tools like Anomalo does could potentially introduce a computational load into the middle of the data pipelines. Can you talk about how tools like Anomalo and your other partners, how do they scale using Databricks?
Yeah, I mean, Databricks has basically an auto-scaling compute layer, one of the best in the industry, actually. So we can anticipate, actually, as we've just G'd our serverless capabilities as well, we have a bunch of AI and ML that are looking at the predictability of the workload and analyzing all the bandwidth that's required. So we can auto-scale the compute layer as necessary. Really, really rapidly, not increasing it only, but also, which is not even more difficult, is to reduce the compute layer that's necessary for that workload. So we're able to apply this variant from either going, up or down based on compute demands, essentially, from the workload perspective. So we have embedded, monitoring at for allowing that auto scaling capability. So if a partner requires more power for running that pipeline, or provided the inquiry, Databricks can do this very well. Actually, it's best of breed in the industry.
Thanks. So, as is usual, we have a relatively alert audience who are streaming a bunch of questions in. So I'm going to say thanks. I'm going to hand it back to Andrew, who's going to field some of the audience questions.
Absolutely. Yeah. Thank you all, gentlemen. That was a great conversation. We'll move into the audience Q&A here. So Zach, first question is for you. How would Anomalo integrate with a hub and spoke data stewardship program?
Yeah, so a hub and spoke data stewardship program is actually the one I'd prefer the most to work with. And there's a few different reasons for that. So one, Anomalo would be monitoring at the hub, 100%. That is the source of truth for everything else. So the CDO office needs to be able to determine, hey, are there any anomalies here that are going to impact some of the spokes? And can we resolve these as quickly as possible with a root cause analysis? Now, that could be done within a specific organization within Anomalo. So that's just managed by the CDO. No one else has to go in there. The different business units don't have to bother checking that yet, because the CDO is able to do that. Now, for all the different spokes, they might want to have their own specific presentation layers. They use the data in very specific ways, and they have very specific use cases. And they want to tailor the anomalies they're looking for those use cases. So in different organizations within Anomalo, each one could be for a different business unit. And because it's looking at subsegments of the data, or it's looking at data in a specific way, the unsupervised modeling can actually get even more nuanced, because it's looking at how does the data change specifically for the data you care about. And I'm just going to ignore all the irrelevant data. And all the key metrics in here are things that this business unit cares about. So notifications for that business unit would go to, for example, Slack channels or Microsoft Team channels or PagerDuty, as well as email. And those would only go to the users who care about it. So it's one about tailoring, detecting anomalies and finding the root cause by different business units, and also at a high level for the CDO. But also making sure that the notifications are managed in a way that people only get what they care about.
All right, fantastic. We'll move on to the next question here. Dennis, we'll start with you, and of course, Zach, if you have something to add, please do so. Dennis, this question is for you. It's a long one, so I'll read it. I'll read it in its entirety. Here we go. I've seen organizations with a growing inventory of data sources and data assets. Some of their expectations are applicable across the board, while others are specific to a data set or two. That means not only are there a lot of data sets and pipelines requiring monitoring, it also means increasing the human burden for data stewards. So, what are some ways to ensure sustainability of data quality monitoring environment, even in the presence of staff turnover?
Oh, that's a loaded question, I would say. Yeah. Look, I mean, this is a challenge that we see all the time. There's a plethora of data attributes, plethora of data sources. And as you're applying the curation process of this data throughout that curation process, and there's a well-adopted industry framework called the medallion process, essentially, as you land your data as is as much as possible without minimal transformation. And as you iterate over that curation process, you'll take that data from your, bronze layer, which is the terminology that we use, often in that industry standard. You take it from your bronze, you might produce a series of silver layers, and those silver layers might as well feed a series of gold layers. So data quality during that process is extremely important, and as well as monitoring that quality, and hence that's why we have partners like Anomalo to help us do that essentially. Otherwise, you basically have to build that yourself. You have to build that monitoring capability along the way, and it's not that simple. And that's exactly why a partner like Anomalo provides that capability, and we have a great integration with them on the Lakehouse platform. Now, having said that, many folks have done over the years, build their own detection. But as the question alluded, as you have a skill set change or new resource coming on board, it's a really hard bar to maintain that process. So I would urge people to look at Anomalo to basically, leveraging their capability and their core competency. They're just iterating over the add-on capabilities of making sure data quality is monitored appropriately. Now, if you look at this medallion process, conceptually, it's really simple. You land your data on a bronze layer, you iterate, you create a silver layer, and then you iterate and you create a gold layer. As you go forward, you will have many of these, curation processes from the same source. So there's going to be a multiplication of data attributes and transformation. And again, I would urge people to look into like a partnership like Anomalo to help them making sure that their quality is up to par.
All right, fantastic. I think we'll
otherwise,
one last question.
This is a core competency that we defer to our partners to be, in all honesty.
No worries there. Okay, so we'll move on to the final question here. I know we're running short on time. So Zach, this will be for you. It's a two-part question. We had a couple people asking about whether or not Anomalo always has to be on and running, or is it just used when data is being ingested? And then can Anomalo run independent, or is Databricks required?
Yeah, so let's go through this in a couple different ways. So Anomalo would likely need to be running constantly. And the reason being, specifically with the unsupervised machine learning models, is that it needs to train on the data to determine how it shifts over time. Now, things like time series models are going to be trained from the very beginning. So they don't really need Anomalo to always be running. They would just need to be running on a daily basis, for example. But the unsupervised model would need that functionality. Also, Anomalo wants to pick up exactly when data arrives. As soon as it arrives, Anomalo wants to run its checks. And it could easily do that by always being on. Now, because Databricks is very scalable, and the clusters or SQL endpoints are going to potentially turn off or scale down while Anomalo is on, it's going to help manage costs and performance. so that it's not taking up too many resources when it doesn't need it. And that's one of the great things about Databricks. Anomaly does work independently of Databricks. There are multiple data warehouse and data lakehouse connectors as well. I will say I've seen a lot of success with Databricks.
All right. Well, unfortunately, this does bring us to the end of our time today. It was a great webinar. Really appreciate everyone's input here. But please allow me to take a moment to thank our speakers. We did, of course, hear from David Lotion with TWI, Dennis Dubois with Databricks, and Zach Wright with Anomalo. We'd also like to thank Databricks and Anomalo for sponsoring today's webinar. And please remember, we recorded today's webinar and we'll be emailing you a link to an archived version of the presentation, which you can feel free to share with colleagues. And if you'd like a copy of today's presentation, once again, you can locate the resource window to download the PDF. Finally, I'd like to remind you that TDWI offers a wealth of information, including the latest research, reports, and webinars about BI, data warehousing, and a host of related topics. So I encourage you to tap into that expertise at tdwi.org. From all of us here, lastly, let me say thank you so much for attending. This does conclude today's event.